Something erupted from Mount Etna that scientists cannot explain, and what they found in the glowing material has sent shockwaves through research labs across Europe. The footage looks almost unreal. A massive column of light rising from the crater, not the familiar orange glow of flowing lava. This was different. The light shimmered white and blue. It pulsed with an almost electric intensity. Scientists on the ground watched in stunned silence. Their instruments screamed with warnings. Every reading spiked beyond the limits of their equipment. And in that moment, standing on the trembling slopes of Europe's most active volcano, these researchers realized they were witnessing something unprecedented. Mount Etna sits on the eastern coast of Sicily. It has erupted hundreds of times throughout recorded history. Roman poets wrote about its fury. Medieval villagers feared its wrath. Modern scientists have studied it for decades. They thought they understood this mountain. They believed they knew what to expect. But on this day, Etna proved them wrong. The volcano revealed a secret it had been hiding for thousands of years. The eruption began without any warning. There were no major tremors in the days before, no unusual gas emissions, no clear signs that something catastrophic was building beneath the surface. Then, suddenly, the southeast crater exploded into life. But this was not a normal eruption. The material that poured from the opening glowed with colors that defied explanation. Witnesses described it as almost supernatural, a bright, shimmering stream of molten material that seemed to pulse with its own inner light. Field teams were already positioned on the mountain when it happened. They had been conducting routine monitoring, collecting samples, checking equipment. When the eruption began, they had only seconds to react. The ground beneath their feet shook violently. Cracks opened in the volcanic soil. Steam and gas vented from fissures that appeared without warning. The air filled with the sharp, acrid smell of sulfur. Visibility dropped as thick ash clouds billowed across the slopes. But the scientists did not run. They could not run. This was the moment they had trained for, the chance to witness an active eruption up close, to collect data that could save lives in the future. So they held their ground, they activated their equipment, and they began recording everything they could. Thermal cameras pointed toward the crater captured readings that made no sense. The temperature spiked far beyond the normal range for volcanic eruptions. Standard lava flows typically measure between 800 and 1200 degrees Celsius. These readings climbed higher, much higher. The instruments struggled to keep up. Some simply failed, overwhelmed by the intensity of the heat radiating from the glowing flow. Drones launched from nearby observation points wobbled in the turbulent air. The thermal updrafts created by the eruption made stable flight almost impossible. Pilots fought to keep their aircraft aloft. The footage they captured was fragmented, shaky, but even these brief glimpses showed something remarkable. The material flowing from the crater did not behave like normal lava. It moved differently, it glowed differently, and when it came into contact with the rocky slopes, it reacted in ways the scientists had never seen before. Pyroclastic surges raced down the mountainside at terrifying speeds. These deadly clouds of superheated gas and volcanic debris can travel faster than a car on a highway. The teams had positioned themselves carefully, staying clear of the main flow paths. But the mountain was unpredictable. Vents opened in unexpected places. New fissures split the ground. The landscape itself seemed to be reshaping in real time. Radio communication crackled between team members. Voices shouted coordinates, warnings, instructions. Everyone moved with purpose, but there was an edge of panic beneath the professional calm. They knew how dangerous this situation had become. They knew that any moment could bring a deadly surge in their direction. Yet they continued their work. Sampling kits clutched tightly. Spectrometers held steady despite shaking hands. Every piece of data could be crucial. One scientist described the scene later as walking through the end of the world. The sky had turned dark with ash. The ground glowed with heat. The air itself seemed alive with energy. And above it all, that strange, impossible light continued to pour from the crater, white and blue, shimmering, almost beautiful if it were not so terrifying. When the first samples reached the mobile laboratory set up near the base of the mountain, the real mystery began. Scientists immediately began analyzing the fragments of glowing material they had managed to collect. They used X-ray diffraction to identify the mineral structure. They expected to see familiar patterns: basalt, volcanic glass, the standard building blocks of Etna's eruptions. Instead, they saw something that stopped them cold. The material did not match anything in the database. Not a single known terrestrial mineral produced the same pattern. The scientists ran the test again. Same result. They calibrated their equipment and tried a third time. Nothing changed. The samples simply did not correspond to any previously identified volcanic material on Earth. Under ultraviolet light, the fragment began to glow. Not a faint luminescence, but an intense, bright fluorescence. Blue and white light pulsed from the small piece of volcanic material. The scientists stared in disbelief. Volcanic samples sometimes exhibit fluorescence, but nothing like this. The intensity was off the charts. Then the gamma sensors activated. The readings spiked immediately, far beyond the normal range, far beyond what any volcanic material should produce. The team exchanged worried glances. Elevated radiation in volcanic samples is not unheard of, but these levels were extreme. Something was very wrong with this material. If you are finding this story as fascinating as we did, take a moment to subscribe to the channel. We bring you the most incredible discoveries from around the world, and you will not want to miss what comes next. Further testing only deepened the mystery. The scientists attempted to melt the sample using laboratory equipment capable of generating temperatures exceeding 1600 degrees Celsius. Normal volcanic glass melts at temperatures well below this threshold. Basalt becomes liquid at around 1200 degrees. But this material refused to change. It sat in the crucible, glowing faintly, completely unaffected by the extreme heat. Spectrometers detected chemical signatures that should not exist in volcanic material. Rare lanthanides appeared in unusual concentrations. Isotopic ratios were unlike anything recorded from Etna or any other volcano on Earth. Trace elements suggested the material had formed under conditions of extreme pressure. Pressures only found deep within the planet's mantle. The implications were staggering. If this material truly originated from deep within the Earth, it represented something extraordinary, a window into processes that scientists had only theorized about, evidence of geological activity far below the surface that had never been directly observed. But how did it reach the surface? Etna's magma chambers are relatively shallow compared to other volcanic systems. The volcano draws its fuel from pockets of molten rock just a few kilometers beneath the surface. For material to rise from the deep mantle, something unusual must have happened. Some conduit must have opened. Some pathway must have connected the surface to the hidden depths of the planet. Video calls and encrypted emails flew between laboratories across Europe. The team in Catania contacted colleagues in Berlin. Berlin reached out to Paris. Paris connected with research centers in London, Madrid, and Stockholm. Everyone wanted to see the data. Everyone wanted to verify the results. And everyone reached the same conclusion. This material was unlike anything ever recorded. The discovery triggered a wave of urgent activity. Scientists who had been working on unrelated projects dropped everything. They needed to understand what Etna had produced. They needed to know what it meant for the volcano's future behavior. Because if the mountain was tapping into previously unknown geological processes, then all existing hazard models could be wrong. Meanwhile, the volcano continued to rumble. The initial eruption had subsided, but the mountain was far from quiet. Sensors recorded hundreds of small earthquakes per hour. Each tremor suggested movement beneath the surface. Magma shifting, pressure building, the mountain preparing for its next outburst. Satellite imagery revealed alarming changes in the volcano's structure. The southeastern flank, which had been relatively stable for years, was now moving. Radar measurements showed the ground shifting outward at a rate that exceeded any historical records. This type of flank movement is extremely dangerous. It suggests that the internal structure of the volcano is under immense stress. If the movement continues, the consequences could be catastrophic. Geologists quickly recognized the pattern. They had seen something like this before, not in their lifetimes, but in the geological record. 7,200 years ago, Etna's southeastern flank collapsed in a massive landslide. The resulting avalanche of rock and debris plunged into the Mediterranean Sea. It triggered a tsunami that devastated coastlines across the central Mediterranean. Ancient settlements were wiped out. Entire communities disappeared in moments. The waves swept across the sea, reaching coastlines hundreds of kilometers away. The scale of destruction was almost unimaginable. And now, sensors were detecting patterns that eerily resembled the conditions before that ancient catastrophe. The parallel was deeply concerning. Modern Sicily is far more populated than it was 7 millennia ago. Cities and towns dot the coastline. Millions of people live within range of a potential tsunami. If Etna's flank were to collapse again, the death toll could be staggering. The economic damage would be measured in billions. The social disruption would reshape the entire region for generations. Scientists were careful not to create panic. They emphasized that the current situation was being monitored closely. They pointed out that many factors would need to align for a major collapse to occur. But privately, in their conversations with each other, the concern was unmistakable. Etna was behaving in ways they did not fully understand. The rules they thought applied to this volcano no longer seemed to hold. Down in the villages that cluster on Etna's lower slopes, life continued in a state of anxious uncertainty. The people who live here have always known the risks. Their ancestors chose to settle on volcanic soil because of its remarkable fertility. Crops grow abundantly here. Vineyards produce exceptional wine. Olive groves thrive in the mineral-rich earth. The mountain gives generously even as it threatens constantly. Families debated what to do. Some began packing essentials. They gathered important documents. They loaded children and elderly relatives into cars. They headed for the relative safety of Catania or other towns further from the volcano. Others refused to leave. They had lived through eruptions before. They trusted that the mountain would spare them once again. Local farmers faced impossible choices. Leaving meant abandoning crops that represented a year's income. Staying meant risking everything. Civil defense advisories shifted from hour to hour. One announcement urged caution. The next warned of imminent danger. The confusion only added to the stress. Elderly residents who remembered previous eruptions shared their knowledge with younger generations. They recalled how their parents and grandparents had responded to the volcano's fury. They spoke of routes that led to safety, of signs that indicated real danger versus the mountain simply letting off steam. This ancestral knowledge mixed with modern science, creating a complex web of information that each family had to navigate. Children practiced evacuation drills while their parents argued about timing. Schools remained open but prepared to dismiss students at a moment's notice. Churches held special services, praying for protection. The community bonds that held these villages together were tested as never before. For people who have grown up in the shadow of Etna, the volcano is more than just a geological feature. It is a presence, a personality, almost a member of the family. They speak of the mountain with a mixture of respect and affection. They know it can kill them, yet they cannot imagine living anywhere else. This complicated relationship shaped every decision they made as the crisis unfolded. Back at monitoring stations scattered across the mountain, scientists worked around the clock. Sleep became a luxury few could afford. Coffee fueled endless hours of data analysis. Every seismograph, every thermal sensor, every GPS station fed information into computer systems that struggled to keep up with the volume of data. Infrasound detectors picked up low-frequency signals emanating from deep within the mountain. These sounds, too low for human ears to hear, revealed the movement of magma through underground channels. The patterns were unusual. Magma seemed to be flowing through conduits that had been dormant for centuries. It was reaching areas of the volcano that had not seen activity in modern times. Thermal imaging showed hot zones expanding along fracture lines on the surface. These glowing paths traced the underground movement of molten rock. They revealed a network of channels far more complex than previous models had suggested. The volcano's internal plumbing was more extensive and more interconnected than anyone had realized. Pressure readings fluctuated wildly. Gas emissions spiked and then dropped without warning. The mountain seemed to be breathing, inhaling, and exhaling in unpredictable rhythms. This chaotic behavior made forecasting incredibly difficult. Normal eruptions follow somewhat predictable patterns. This was anything but normal. Analysts noted that small tremors were triggering reactions across wide areas of the volcano. A minor earthquake on one flank would produce responses kilometers away. This interconnected behavior suggested that the entire volcanic system was under stress. It was like a pressure cooker with multiple weak points. Any one of them could fail at any moment. The unknown material continued to puzzle researchers. Additional samples were collected and distributed to laboratories across Europe. Each facility applied its own specialized techniques. Electron microscopy revealed crystalline structures at the microscopic level that nobody could explain. Chemical analysis detected elements in combinations that seemed impossible under normal geological conditions. Some scientists proposed that the material represented a new high-pressure phase, Perhaps extreme conditions deep within the Earth had created mineral structures that simply did not exist closer to the surface. Others suggested the possibility of contamination, though every protocol had been followed meticulously. A few quietly wondered if they were witnessing something truly unprecedented, a glimpse of geological processes that humanity had never directly observed. The implications extended far beyond Etna. If this material revealed previously unknown deep earth processes, it could change understanding of volcanism worldwide. Other volcanoes might harbor similar hidden chambers. Other eruptions might produce similar mysterious materials. The entire field of volcanology might need to be reconsidered. Simulations ran continuously on powerful computer systems. Scientists modeled potential scenarios based on the incoming data. Some models predicted continued low-level activity followed by gradual calming. Others projected escalating eruptions. A few suggested the possibility of flank collapse, though these outcomes remained at the extreme end of probability. The models struggled with the unknown material. Its properties did not fit existing parameters. Its behavior could not be accurately predicted, so the simulations included wide ranges of uncertainty. The conclusions they produced were hedged with caveats and warnings. The truth was that nobody knew exactly what would happen next. As hours turned into days, the world began to pay attention. International news organizations dispatched crews to Sicily. Camera operators captured footage of the smoldering volcano while reporters explained the developing situation to global audiences. Scientists found themselves giving interviews between data analysis sessions. They tried to communicate the seriousness of the situation without causing unnecessary panic. Social media filled with speculation. Some posts claimed inside knowledge of secret government preparations. Others dismissed the entire event as media exaggeration. Conspiracy theories flourished in the information vacuum. The lack of clear answers from the scientific community created space for wild speculation and unfounded claims. Local authorities worked to maintain calm while preparing for potential emergencies. Evacuation routes were reviewed. Emergency shelters were prepared. Medical facilities stocked supplies. The machinery of disaster response moved into position, ready to activate if the situation deteriorated. Throughout this period, the volcano continued its ominous performance. Eruptions came in bursts. The strange glowing material continued to appear, though in smaller quantities. Each new sample was immediately secured and sent for analysis. Each result confirmed the same impossible findings. The material remained a mystery. Scientists debated the significance of their discovery in conference calls that stretched deep into the night. Some argued for caution, suggesting that jumping to conclusions could damage scientific credibility. Others insisted that the findings were too significant to downplay. They pushed for immediate publication, even in preliminary form. The scientific process, usually measured and methodical, strained under the pressure of events. The stakes could not have been higher. If Etna was indeed entering a new phase of activity, millions of lives could be affected. If the strange material indicated deep geological changes, the implications extended far beyond Sicily. This was not just a local emergency. It was potentially a window into planetary processes that shaped the entire Mediterranean region. And still the mountain rumbled. Still the sensors recorded their endless stream of data. Still the scientists worked to understand what was happening beneath their feet. The answers remained frustratingly elusive. Every new piece of information seemed to generate more questions than it resolved. We have covered many incredible stories on this channel, but few have fascinated us as much as this one. If you want to stay informed about developments like these, hit that subscribe button and turn on notifications. Now let us continue with what scientists believe might come next. The question that haunted every researcher was simple but terrifying. What if this was just the beginning? The historical record suggested that Etna's most destructive events often came in sequences. Major eruptions triggered landslides. Landslides caused tsunamis. Each event cascaded into the next, multiplying the destruction. The 7,000-year-old catastrophe was not an isolated incident. Geological evidence suggested that similar events had occurred repeatedly throughout Etna's long history. The volcano existed in a cycle of building and collapse, construction and destruction. This cycle operated on timescales far beyond human experience. Millennia passed between major events. Generations lived and died without witnessing the mountain's full fury. But the patterns did not care about human timescales. When conditions aligned, the volcano responded according to its own internal logic, and the current data suggested that conditions were shifting in worrying directions. The southeastern flank remained the primary concern. This massive section of the volcano had been slowly sliding toward the sea for years. The movement was normally imperceptible, measured in millimeters per year. But recent data showed acceleration. The flank was moving faster. The internal stresses were building. If the flank were to fail catastrophically, the resulting landslide would be enormous. Cubic kilometers of rock and debris would plunge into the Ionian Sea. The displacement of water would generate waves of incredible power. Coastal communities throughout the region would have only minutes to react. Scientists modeled the potential wave heights. They calculated arrival times for different coastlines. They estimated the zones that would be inundated. The results were sobering. Even under moderate scenarios, the damage would be severe. Under worst-case projections, entire cities could be overwhelmed. These findings were not shared widely. Authorities feared the reaction such information might provoke. Mass panic could cause more immediate harm than the theoretical future threat. So the data remained within scientific and governmental circles, informing emergency preparations, but not public discourse. Yet the people living on Etna's slopes sensed that something was different this time. The rumbling was louder than they remembered. The ash falls were more frequent. The strange glow from the crater at night filled them with unease. They did not need scientific models to feel that their mountain was changing. Ancient traditions mixed with modern anxiety. Some consulted astrologers and fortune-tellers. Others placed their faith in religious observances. Many simply watched the volcano and waited, trusting their instincts to tell them when flight became necessary. As days passed without major disaster, a strange normality began to return. Shops reopened. Schools resumed regular schedules. The initial wave of evacuees began trickling back to their homes. The immediate crisis seemed to be subsiding, even as the underlying threat remained. But scientists knew that volcanic systems often behave this way. Periods of intense activity alternated with apparent calm. The quiet intervals could last days or weeks. They could even stretch into months or years. Then, without warning, the violence would return, often worse than before. The unknown material remained the most disturbing element of the entire event. Every analysis confirmed its anomalous nature. Every test raised new questions. The scientific community had never encountered anything quite like it. Some compared the discovery to finding an artifact from another planet. The comparison was not entirely unfounded. The material's properties suggested formation conditions that simply did not exist near the Earth's surface. Extreme pressures, incredible temperatures, chemical environments that would only be found hundreds of kilometers below ground. Yet here it was, ejected from a volcano that supposedly drew its magma from depths of only a few kilometers. Some researchers proposed exotic explanations. Perhaps Etna had somehow tapped into a deep mantle plume. Perhaps a conduit had opened that connected the surface to the planet's hidden interior. Perhaps processes that normally occurred only in the deepest reaches of the Earth had somehow manifested at the surface. Others remained skeptical. Extraordinary claims required extraordinary evidence. Before accepting such revolutionary interpretations, every conventional explanation needed to be ruled out. The scientific method demanded caution, even in the face of apparently remarkable findings. The debate would continue for years. Papers would be published, conferences would be convened, careers would be built on analyzing the mysterious material. But the immediate concern was more practical. What would Etna do next? And how could people be protected from whatever was coming? Monitoring continued without pause. Every sensor remained active. Every data stream was analyzed in real time. The scientists had done everything in their power to understand the volcano. Now they could only watch and wait. The mountain had its own schedule, its own agenda, its own vast timescale that made human concerns seem insignificant. Whatever processes were unfolding beneath the surface would continue regardless of human observation or intervention. The volcano was a force of nature, untamable, unpredictable, ultimate. For the people of Sicily, life would go on in the shadow of uncertainty. They would plant their crops, they would tend their vineyards, they would raise their children, and always, in the back of their minds, they would remain aware that the ground beneath their feet was merely a thin shell over an inferno. Etna has stood for hundreds of thousands of years. It will likely stand for hundreds of thousands more. In the long sweep of geological time, this eruption was merely a moment, a heartbeat, a brief flicker of activity in an ongoing story that began before humans existed and will continue long after we are gone. But for those who witnessed the strange glowing material, for those who recorded the impossible data, for those who fled their homes or chose to stay despite the danger. This was not a footnote in a geology textbook. This was their lives, their families, their futures hanging in the balance. The volcano does not care about human hopes or fears. It operates according to its own rules, rules we are only beginning to understand. And sometimes when the conditions are right, it reminds us just how small we truly are. What emerged from Mount Etna during those extraordinary hours may take decades to fully understand. The mysterious material challenges everything scientists thought they knew about volcanic processes. The structural changes detected in the mountain raise questions about long-term stability that cannot yet be answered. The parallels to ancient catastrophes demand serious attention. Perhaps this eruption was merely a spectacular anomaly, a strange but ultimately insignificant event in the volcano's endless cycles of activity. Perhaps the unknown material was an artifact of unusual but explainable conditions. Perhaps the flank movement will stabilize. Perhaps everything will return to normal. Or perhaps we witness the opening act of something far larger. Perhaps Etna is awakening in ways that have not been seen for millennia. Perhaps the deep processes that created the mysterious material are signaling changes that will reshape the entire region. We cannot know for certain. The mountain keeps its secrets. It reveals only what it chooses to reveal. And as scientists continue their investigations, as satellites track the shifting ground, as sensors record every tremor and temperature spike, one truth remains absolute. The Earth is alive. Its interior churns with unimaginable energy. And occasionally, through volcanoes like Etna, it reminds us that we are merely passengers on a planet whose power we can never fully control. What happened on Mount Etna was not just a volcanic eruption, it was a message from the depths of our world. And perhaps the most unsettling part is that we do not yet know how to read it.